Imagine a mind. Not born of flesh and blood but of silicon and code. This is the essence of artificial intelligence, or AI. It is humanity's grand attempt to recreate intelligence, to build machines that can learn, reason, and perhaps even create. AI is not just a field of computer science, it is a profound exploration of what it means to think. It challenges our understanding of ourselves and our place in the universe. So what exactly is AI? Think of it simply, it's about making computers smart enough to perform tasks that usually require human intelligence. This includes things like understanding language, recognizing faces in a crowd, or making complex decisions. Some AI is designed for specific tasks like playing chess or driving a car. This is often called narrow AI. Other researchers dream of general AI, machines with the broad, adaptable intelligence of a human being. We are not quite there yet, but the journey is fascinating. AI can process vast amounts of data, far more than any human brain. It can see patterns that we might miss. This power, this potential, is why AI is becoming so important in our modern world. Understanding AI is no longer just for scientists. It's for everyone who wants to understand the world we live in and the world we are building for tomorrow. Why does AI matter so much? Consider the universe. It's filled with information, from the dance of galaxies to the intricate code of DNA. Humans have always sought to understand this information, to find patterns, to make sense of it all. AI provides us with a powerful new set of tools to do just that. It can sift through mountains of data at incredible speeds. It can learn and adapt. This ability to process and understand information is transforming every field of human endeavor, from medicine to astrophysics, from art to archaeology. AI is our new lens on reality. Think about the challenges we face as a species: climate change, disease, resource scarcity. These are complex problems. They require innovative solutions. AI can help us model complex systems. It can help us predict future trends. It can help us design more efficient and sustainable technologies. For example, AI can optimize energy grids. It can help develop new materials. It can personalize medicine for individual patients. The potential to improve human lives and the health of our planet is immense. Beyond solving problems, AI is also a catalyst for discovery. It can help us ask new questions. It can help us explore new frontiers of knowledge. The dream of artificial beings is not new. It's as old as storytelling itself. Ancient myths from around the world tell tales of animated statues, clockwork automatons, and thinking machines. Think of Talos, the giant bronze automaton in Greek mythology who protected Crete, or the Golem of Prague, a creature molded from clay and brought to life. These stories reflect a deep-seated human fascination with creating intelligence, a desire to understand the spark of life and consciousness. The philosophical seeds of AI were sown much later, during the Enlightenment and the rise of scientific reasoning. Thinkers began to explore the nature of thought itself. They asked, is the mind like a machine? Can reasoning be broken down into logical steps? The true journey towards modern AI began in the 20th century, with the advent of computers. The term artificial intelligence itself was coined in 1956. After the Dartmouth workshop, the early years of AI were filled with excitement and high expectations. Researchers developed programs that could solve algebra problems, prove logical theorems, and speak simple English. These were impressive feats for their time. They demonstrated that machines could indeed perform tasks that seemed to require intelligence. One famous early example was the logic theorist program, which could prove mathematical theorems. Another was Eliza, an early chatbot that could simulate a conversation with a psychotherapist. However, the initial burst of progress was followed by periods of slower development, sometimes called AI winters. The problems turned out to be much harder than initially anticipated. Creating true intelligence required more than just clever programming. It required vast amounts of computational power and, crucially, vast amounts of data. Early computers were slow and expensive, and large datasets were not readily available. The resurgence of AI began in the late 20th century and accelerated dramatically in the 21st. Several factors contributed to this AI spring. Key breakthroughs in algorithms also played a vital role. So, how does AI actually work? How does a machine learn? It's not magic, though it can sometimes feel that way. At its heart, much of modern AI relies on a concept called machine learning. Think of it like teaching a child. You don't program a child with explicit rules for every single situation. Instead, you show them examples. You say, "This is a cat," and show them a picture of a cat. You show them many different cats. Eventually, the child learns to recognize a cat, even one they've never seen before. Machine learning works in a similar way. Instead of pictures of cats, AI models are fed data. Lots and lots of data. This data could be images, text, numbers, or sounds. The AI model looks for patterns in this data. It tries to figure out the underlying rules that connect the input data to the desired output. For example, if you want an AI to identify spam emails, you feed it thousands of emails, some labeled spam and some not spam. The AI analyzes the words, the sender, and other features. It learns which patterns are most common in spam emails. There are different ways AI can learn. One common method is supervised learning. One of the most powerful tools in the AI toolkit today is something called a neural network. The name itself gives you a clue. These systems are inspired, at least loosely, by the structure and function of the human brain. Our brains are made up of billions of interconnected neurons. These neurons transmit signals to each other. This vast network of connections is what allows us to learn, think, and perceive the world. Artificial neural networks try to mimic this biological architecture, but in silicon. They are the engines driving much of the current AI revolution. An artificial neural network is made up of layers of interconnected nodes, or artificial neurons. Each connection between nodes has a weight associated with it. This weight determines the strength of the signal passing through that connection. When you feed data into the input layer of the network, the nodes in the first layer process it. You might think AI is still confined to research labs or futuristic movies. But the truth is, AI is already deeply embedded in our daily lives. It's often working silently in the background, making things smoother, faster, or more personalized. Consider your smartphone, the predictive text that helps you type faster, AI, the voice assistant that answers your questions, AI, the camera that automatically adjusts settings for the perfect shot. You guessed it, AI. These are not just conveniences, they are examples of narrow AI performing specific tasks with remarkable efficiency, shaping our interactions with technology. Think about your online experiences. When you shop online, AI algorithms recommend products you might like based on your past purchases and browsing history. When you stream movies or music, AI suggests what to watch or listen to next. Social media platforms use AI to curate your newsfeed, showing you content they think you'll find engaging. Search engines use incredibly sophisticated AI to understand your queries and deliver relevant results in fractions of a second. This invisible hand of AI is constantly shaping the information and choices presented to us in the digital realm. Beyond our personal devices and online interactions, AI is transforming entire industries. In healthcare, AI is helping doctors diagnose diseases earlier and more accurately by analyzing medical images like X-rays and MRIs. Gazing into the future of AI is like predicting a comet's path. It's moving fast and it's powerful. Its ultimate path holds many unknowns and immense possibilities. AI will continue to evolve at an accelerating pace. Expect AI to become more capable and integrated into our lives. The journey is just beginning. AI could help us cure diseases, combat climate change, and elevate human creativity. However, with great power comes great responsibility. The development of advanced AI also brings significant challenges and ethical dilemmas. We must grapple with questions of bias and employment impact. Open discussion, thoughtful regulation, and a commitment to ethical principles are essential. The future of AI should not be decided by a few, it must be a shared human endeavor. As we venture further into the era of artificial intelligence, one question looms large. How can we ensure that AI remains safe and beneficial for everyone? AI's immense potential comes with its own set of risks. Misaligned objectives, lack of transparency, and unintended consequences could lead to hazardous outcomes. Imagine an AI system designed to maximize efficiency, but inadvertently causing harm, because it doesn't fully grasp the nuances of human values. To mitigate these risks, robust safety measures must be implemented. This includes developing AI with transparency, ensuring that its decision-making processes are understandable and explainable. Additionally, rigorous testing and continuous monitoring are essential to identify and rectify potential issues before they escalate. Ethical AI development also demands collaboration across industries, governments, and academic institutions. Comment if you want to know more about the safety of AI and how it can turn hazardous. Like and subscribe to know how that works for more such videos.